A landscape architect wished to enclose a rectangular garden on one side by a brick wall costing $40 per foot, and on the other three sides by a metal fence costing $10 per foot. If the area of the garden is 48 square feet, find the dimensions of the garden that minimize the cost. Okay, this diagram represent our problem. This is a rectangular garden. This is the brick wall. This is the enclosing that we are going to do via this metal fence, right? So goal, minimize cost, right? Let's see represent our cost function. So if we let X represent this dimension and Y represent this other dimension, then our cost should be equal to 40 times X for the brick wall, right? Plus for the metal fence around here, twice Y plus X times $10 per foot here, right? 10. So our cost function should be 40X plus 20Y plus 10X, right? 10X. Simplifying, our cost function would be 50X plus 20Y. Now, we have a constraint. A limitation, which is this: the area should be equal to 48 square feet, right? Square feet. So, which means that X times Y, no matter how we construct this rectangular shape, should be equal to 48. From here, dividing both sides by X, we can get that Y should be equal to 48 divided by X, right? Now, if we substitute this into our cost function here, we're going to get that the cost function will be 50X plus 20 times 48 over X, which is equal to 50X plus 20 times 48 is 960 over X. All right, now let's just rewrite our cost function as follows: 50X plus 960 times X raised to minus 1. Because next I will find the critical points of this cost function by setting the derivative equal to 0, right? Yeah. So if we set the derivative of this function equal to 0 and solve for X, we're going to get the critical point of this cost function. So set now C prime equal to 0 and solve for X. Derivative of this function will be 50 minus 1 coming down minus 960 times X raised to minus 1 minus 2. That should be equal to 0. This leads to the following: 50 equal 960 X raised to negative 2, which in turn is just equal to the following: 50 equal 960 over X squared, multiplying by X squared both sides. 50 equal, or 50 times X squared, better said, equal 960, right? Now, which means that X squared is 960 divided by 50 both sides. And finally, X equal 960 over 50, square root of that. But what is that? Let's calculate this in our Desmos Scientific Calculator. Square root of 960 over 50. 4.38, rounding this number to decimal places. 4.38. Let's write it down. 4.38. In the end, you may attach the units. We're dealing with feet for the length, so feet. And y, what is the value of y? Remember, y depends on x. It's 48 divided by x, right? So we can compute that. Y equal 48 divided by 4.38. This is 10.958. Rounding this to two decimal places, 10.96. 10.96. 10.96 feet, right? Feet. Great. Now, the last thing we should do is just to verify that these two values actually lead to the minimum cost, right? For that, think about it. If x approaches 0, right? If x is very small, then y, not y, c, the cost function, right? Will go where? Well, if you look at this cost function, if x is close to 0, this will go to infinity, right? But this will go to 0, so the cost will go to infinity. If x approaches to infinity, if x is a huge number, then the cost, where will it approach? Well, then if you substitute a huge number for x here, imagine a billion, a trillion into this guy, 0, right? 0. But a big number times 50, infinity, right? So then the cost goes to infinity. What does it mean? It means that if you're close to 0 for your value of x, then the cost goes to infinity. If your x is big, also goes to infinity. It means that in between, given that the function cost here is continuous for x bigger than 0, in between, right, should achieve its minimum. So this guarantees that these two values that we found here will indeed lead us to the minimum cost. That is all. Thank you for watching. Please subscribe to our channel. More videos coming up.